So I'm here to continue the chemical kinetics. So in my previous video or previous class on the chemical kinetic, I've discussed the chemical kinetics as the aspect or one of the branch of chemistry which deal with the study of rate of chemical reaction and the mechanism of the words of the reaction. So under this chemical kinetics, I've explained the rate of chemical reaction. After rate of chemical reaction, I explained the rate curve. After the rate curve, I explained rate law, then rate equation. So the rate law tells us the relationship between rate of reaction and the concentration of what? Of reactants. So the rate law is the one that leads us to what we call orders of reaction. And I explained orders of reaction with different types of orders of reaction we have from 0 seconds, 0.4 seconds, and we also have thought up to the nth order. So I discussed the orders of reaction with their words, graphs. Like that's where we stopped in what? In my after the orders of reaction, I explained the collision theory. We say that before a chemical reaction can occur, there must be an effective collision between the two reacting what? Particle. So the collision theory leads us to what we call what? Arrhenius theory or ionization theory, which brings about the ionization energy as the minimum amount of energy that required before a chemical reaction can take place. So after that, I discussed what the Arrhenius equation and how are you going to use Arrhenius equation to calculate this rate constant and ionization energy. And we support it with what is graph, and then we solve two or more questions under Arrhenius equation. So the next aspect of chemical kinetics we are going to treat now is what we call what? Reaction kinetics. What? Reaction kinetics. What is reaction kinetics? As we all know that anything kinetics simply means what? The movement or motion. The kinetics always talk about the motion or movement of of a particle. So the reaction kinetics is an aspect of chemical kinetics which deal with the study of factors that affecting the rate of chemical reaction. Once again, the reaction kinetics is a subtopic under chemical kinetics which deal with the study of factor that affecting rate of chemical reaction. And the factor which affect the rate of chemical reaction include concentration of reaction, include temperature, include surface area, include nature of reactants, include light. Then so we have presence of what? Of catalyst. So these are the what? The six factors that affecting what? The rate of chemical what? Reaction. Let's take the factors one after the other. The first one is concentrate, concentration. What is the effect of concentration on the rate of chemical reaction? See, when the concentration of the reaction is what? Is being increased, the rate of reaction will also what? Increase. That is, the increase in concentration of the reaction lead to the what? Increase in what? Rate of chemical reaction. So when the conc of what? Of the reaction is increased, the rate of chemical reaction is also what? Also increase. The effect of concentration of a on rate of chemical reaction, it's already explained by what? By rate law, which states that what? The rate of reaction is proportional to what? To concentration of what? Of reaction. If we have A reacts to give us what? Product. So the rate will have to the what? Conc of what? Of A. So this is rate what? Rate law. This statement tells us that what? When the conc of the reaction A is being increased, the rate of reaction will also what? Also increase. And the effect of what? Of concentration can be put on the what? On the graph. So we can put it on the graph in this form. If you have what? This is what is time. This side is what? Amount of what? Of reactant or product. And if you are plotting the graph of effect of what? Of concentration, first graph can be in this form. The second graph can be in this what? In this form. You can observe that what? This turning point here, this particular point here, where the what? The graph stop here, this point here, this particular point here, we have it here, and we also have it what? Here. So the point here is what we call what? End point. End what? End point of the what? Of the reaction. So now at what? We have two curve here. This what? Curve Y. This one is what? Curve A. We have Y and we have X. Abi? That's the reaction. So from this graph now, the X represents what? Graph of higher what? Higher concentration. Higher what? Concentration. Where what? Y represents what? Graph of what? Of lower what? Lower concentration. So the time taken, this X with the T1, here we have what? T2. So the time taken for X to react completely is what? Is T1. So for this Y to complete its own reaction to reach the what? Endpoint, it's what? T2. You can see what? See that what? The X complete its own reaction with shortest time. Where what? It's still the T2 is the time taken for the what? For Y to complete its own reaction. So this curve here, the one inside here represents what? Lower concentration. The one outside there represents what? Higher what? Concentration. So they can ask you that what? Which of the two curves that is the reaction is what? Will be slow. Is be what? Y. Lower the concentration. Then lower the what? The rate of chemical what? Reaction. That's as per that. The next one is what? Effect of what? Of temperature. If you look at what? Effect of what? Of temperature. The temperature on the rate of what? Chemical reaction. The temperature, in fact, for any reaction, here we are less concerned about what either reaction is exothermic or endothermic. So for any chemical reaction, whenever the temperature is being increased, is a must, the rate of reaction is also what? Also increase. When the temperature of the reaction is what is increased, the rate of what? Of reaction is also what? Also increase. So, but when temperature of a reaction is what is decreased, the rate of chemical reaction also what? Decrease. Or for example, let me use this as a case of study. If you have a beaker here, this beaker A, call it what? This beaker what? Beaker A. And we have another what? Beaker, which is what? Beaker B. And this beaker A is contains water. And this beaker B also contains what? Water. And two of them have what? Also contains what? Water. So we have water here, we have what? Water here. If heat should now apply to the two, we apply it, sorry, we apply it to this one. That is, this water here will be what? Hot what? Water. And the water we have here is what? Cold water. So if I'm now trying to what? To put a spoon of two spoon of a what? Of a tea. Let me put like a bonfita. If you put what? One spoon of a what? Of a bonfita inside this, and then one spoon of bonfita inside what? Inside cold water and hot water. I want to prepare tea with bonfita. So you now put what? A spoon of bonfita on what? On hot water, a spoon of bonfita on the cold water. Which of the two that will dissolve the bonfita quickly? You can perform the experiment. You observe that for the warm water, immediately the bonfita gets into the warm water, it will dissolve. But if one bonfita gets to the cold water, it will be float. It will not dissolve what? Easily. It will take more than 2 to 3 minutes before it can dissolve. But if it's warm water, instanta, it will be what? It will dissolve. You can now see that what the temperature of what? Of this warm water, of hot water, and assuming it be around what? 100 degrees C. And this cold water, let me say, is around what? 5 degree what? Degrees C. So you can see that what? The water of higher temperature dissolve the what? The tea faster than what? The water of lower what? Temperature. So when the temperature is what? Is being increased, the rate of reaction is also what? Increased. When the temperature of the reaction is what? Is being decreased, the rate of reaction is what? Is also what? Decreased. So that's for the temperature. The next one is what? For surface area. If you look at surface area, surface what? Area of reactants. Of what? Of reactants. So the surface area of a reactant of a reaction it represents or is represent the state at which the reactant of the reaction occur. Is the one I tell us what the state at which what the reactant of reaction is what occur. So when the surface area is what it can exist in what in three form. Can exist in three form. Yes, we have in solid, in powder, solid chips and what and a powder form. Or you can also call it what? It exists in what? Lump. Yes, so the action of lump is less than what? Grander. And grander less than what? Powder form. This is how what the rate of what of reaction occur in what in the this. This lump is in what in solid form. Grinder, they have grounded it like in terms of what it be like chips. This is the powdery what powdery form. So the rate of what of reaction of chemical reaction at the powder level is far greater than that of what of lump. It's just like you have a cube sugar. Yes, the cube sugar and the sugar in form of millet. One. So if you put what cube sugar here and the cube sugar and a sugar in form of what or powder or millet like this, dissolve them in what in water at the same time, in cold water at the same time. You will observe that what the sugar in powdery form would dissolve faster than what the sugar in what in the cube form, because this one is what is have what light surface what surface area. That's the same reason applicable to us if you eat biscuits or bread or yam. You will find it difficult to what to swallow them. You will first of all use our what our upper jaw and lower jaw teeth to what to grind and break it to break them. So the process of chewing by what by our mouth, we are trying to what to increase the surface area of the food we inject. So when the surface area is what is being increased, this salivary gland, which contain the enzyme taline, will not act on it. The food digestion will be what will be easier, but we find it difficult to what to swallow the what cube of biscuits or bread. We must first of all what chew them in order to what to increase the surface area, and it will help us to and it will help us to aid the digestion. So when the surface area what is being increased, the rate of digestion is also what also increased as well. So and this thing you can put it on the graph too, like this. This is a graph of rate of chemical what of a factor the effect of surface what surface area. This is with what amount of reactants products. So we have it in this form. This is the first one. This is the second one. This is what the third one. Can you see it now? Yeah. Can see that at this point, this is the time at which this first one here reached the what? The end point. This is what the point where what the second one reached the what point. This is the point where what the third one reached the what the end point. So yeah, so this is this graph here we have here is the one that represents what the powdery form. Powder what form. This one is what that represents what the gander. This one represents what solid. So which of the curve that the reaction is what is the faster is what the powdery form. So with the same thing as what the effect of what of concentration. So just note that what the increase in surface area lead to the increase in rate of chemical reaction. Decrease in surface area lead to the what decrease in rate of chemical reaction. The next one is what nature of what reactants. Look at the nature of reactants. Some textbook they treat the surface area, they put surface area under the nature of what of reactants. They are almost what the same. The nature of reactant simply means what the type of substance we have in the reactant will determine the what the rate at which what the reaction will occur, the speed at which what the reaction will occur. So and we all know that what the state of matter exists in three forms: solid, liquid, and what and gas. So the reactant, if the reactant of the reaction is in solid, is less react than what? Than liquid, and liquid is less reactive than what? Than gas. This is what? Increase in what? In reactivity of what? Of state of what? Of matter. So which is almost the same with what? The surface what? The surface area. So the graph of the nature of what? Reactants is, we also have it in what? In this form too. It's really the same thing with the one we have here for the second one, the third one. So, and this place will be what? This is what? T what? T1. This place will be what? T2. This will be what? T what? T3. So let me call this what? We have P, Q, R. So from the graph there, the P represents what? Solid. Sorry, P represents gas. And we have what? Q represents what? Liquid. And R represents what? So what? Solid. So the solid is what? Is less what? Reactive. And the most reactive state of matter is what? Is gas. And the next one, which is the other effect of what? Of factor that affects what? Rate of chemical what? Reaction. We have effect of what? Of light. Talking of what? Of light. So the light also what? Affects the rate of chemical what? Of reaction. So the light affects the rate of what? Of chemical what? Of reaction. And the example of the reaction in which light is being affected, we have what? Photochemical what? Reaction, which is what? A reaction between what? We have some reaction, they are what? They are photocatalyst. Photo what? Catalyst, list in what? In nature. So we have some reaction that are what they are photocatalyst in nature, that this light serve as what? As catalyst for them, which speed up the what? The rate of what? Of reaction. Take for example, the reaction between HCl, hydrogen gas, and chlorine what? Gas. This reaction is very what? Very slow in a dark region to form what? Hydrogen what? Fluoride. The reaction is what? Is very slow at what? In a dark region. But when what the reaction is what is being exposed to what? To light. When the air is being exposed to what? To light, the light will speed up the what? The rate of the what? Of the reaction. So this reaction is also a what? A good example of what? Of photocatalyst what? Reaction. A reaction in which what? This light serve as what? Sunlight serve as catalyst, which speed up the what? The rate of what? Of the reaction. And we can also have what? Halogenation of what? Of alkane. Halogenation of what? Of alkane by taking what? CH what? CH4 methane. First member of alkane is methane gas. React with what? Halogen. Let me use what? Chlorine. Yeah. So this reaction is also slow in the absence of what? Of light. So we use what? Light as what? As catalyst for what? For this reaction to give us what? Chloromethane plus what? H what? HCl. So this reaction is also another example of a reaction in which light serves as what? As catalyst for. And we also have another reaction, which is what? Photosynthesis. Yes. Photosynthesis in what? In the green plant is also a good example of what? Of photocatalyst what? Reaction. Is a process whereby green plant can manufacture their own food by making use of what? Of CO2, water, in the presence of what? Of sunlight, will serve as catalyst to give us glucose. So here you can have what? With this as case of solid, you can have CO2 react with what? H2O in the presence of what? of sunlight to give us C6H12O6 plus 6 mole of oxygen what? Gas. Here we have 6, we have 6. But what is the catalyst in the what? In this reaction, we have what? Light. It's also a what? A photo what? Catalyst what? Reaction. And so those are the what? The common example of photocatalytic reaction. The presence of light in some reaction increase the rate of what? Of the chemical what? Reaction.